kids, welcome back to Common Core Algebra 2. Today's lesson is 4.6, Exponential Modeling with Percent Growth and Decay. Now this is not a new topic. We talked about exponential growth and decay back in Algebra 1. And if you remember, now I like to use a different formula than sometimes they give us. I will talk about what the formal formula is later on in the lesson. But I always like to say that our principal is equal to our initial times 1 plus or minus the rate, depending on whether we're increasing or decreasing, raised to the time. Now we'll come back and we'll talk about that some more, but that should be the formula you're kind of familiar with. So exercise 1, suppose that you deposit money into a savings account that receives 5% interest per year on the amount of money that is in the account for that year. Assume that you deposit $400 into the account initially. Initially, hopefully you're realizing where that word comes in. So how much will the savings account increase by over the course of 1 year? Well, hopefully even a fourth grader can figure this out, because we can figure out that $400 times, now 5% interest. I like to say this, it's probably not correct, but only stupid people use percent. Mathematicians have to use numbers. And 5% as a number, if we take 5 and we divide it by 100, we get 0.05. So if we multiply 400 times 0.05, we get $20. So that's how much it is increased by. B says, how much money is in the account after the end of the year? Well, easily enough. We know we started with 400. We added $20 interest, which is awesome, by the way, and you get $420 in the account at the end of the year. C says, by what single number could you have multiplied the 400 by in order to calculate your answer in part B? Now, hopefully you remember this. I can remember doing this in finding sales tax, like when you found, the price of a dress, including the sales tax attached to it. So then you'd say, well, you have to add the sales tax in, but you want to calculate how much the dress and the sales tax would cost. This is the same kind of a situation. So if you take that 400 and you multiply it not only by the 0.05, but I'm going to remind you back up here where I put 1 plus the rate up here at the top, that 1 gives me my initial amount back again. So I put 1 plus the rate is 0.05, and when you multiply that, so 400 times 1.05, that's when we get the $420 back, right? Because that 1 tells me $400 plus the additional 5% that's added on. So the actual answer to this one is going to be right here. 1.05 is the answer to this one. Using your answer from part C, determine the amount of money in the account after 2 and 10 years. So we can use the same formula and do 400 times 1.05 to the second power after 2 years, and 400 times 1.05 to the 10th power for 10 years. So doing the math quickly, this is equal to 441, and this is equal to 651.56. Now make sure this one says round all answers to the nearest cent. I'm going to remind you that means to the nearest hundredth, because money is 0.56 is nearest hundredth. Okay? E says give the equation for the amount. So this is basically the same equation we've just been talking about, except it's telling us to call it S of t, which is equal to our initial amount, 1 plus the rate, raised to the, in this case, they're using t as our independent variable. F says, using a table on your calculator, determine to the nearest year how long it will take for the initial investment of $400 to double. And it says, provide evidence to support your answer. So go to your calculators. If you're at home, you're not going to be able to do this, but I can show you what we're talking about. So just hold on a second, and I'll pull up a table on our calculator. Okay, bam, there we go. So if you were going to pull this table up on our calculator, you would put this into your calculator under your graphing icon, and you come up with the table here, because what we're looking for is for when the investment doubles to 800. Now, somebody made a really good point today, because I was thinking it was closer to 14 years, but at 14 years, it hasn't quite doubled yet. So I don't think we can say 14 years. I think we have to wait 15 years in order for our money to double. So that was a really good point. So in this case, I would say provide evidence. I just showed this table. You would maybe write the table down, because you obviously wouldn't be able to capture it like I did. So I would say it will take about 15 years for our investment to double to, I'm even going to be specific, $800.
Waiting outside. Jordan Konike, your ride is waiting outside for you.
Okay, so write down what you need to, and then we can move on. All right, so once again, this is the formal definition. If quantity Q is known to increase by a fixed percentage P in decimal form, then Q can be modeled by Q of T is equal to Q naught. That zero at the bottom is called Q naught. It always means the initial amount of Q. All right, so Q naught times 1 plus P raised to T. So as you can see, this is the same formula I just started with, because I just said Q naught is equal to the initial amount, 1 plus, and P is going to be the rate. Make sure it's in decimal form, raised to the time. Okay? You can write it down. You don't have to write it down. Somebody asked today, if I know the formula as I just wrote it, initial times 1 plus or minus the rate, depending if we're increasing or decreasing, raised to the time, do I have to know the formal formula? And the answer is no. You just have to be able to apply it. Exercise 2. Which of the following gives the savings S in the account of $250 if $250 was invested at an interest rate of 3% per year? And like I was just telling my 9th period class, right, guys, don't look at the answers, because they're very deceiving. These multiple choice questions are not nice. They are here to trick you, so don't look at them. Remember what your formula is. So in this case, they call it S is equal to the initial amount, which we're told is $250. And then it's going to be, because we're assuming it's going to be increasing, it actually doesn't say it's growing, but I'm hoping that if you're putting money into a savings account, the money is growing, because if you're losing money, you need to change your account. So 1 plus the rate. Now the rate is 3%. And once again, we don't use percent, we use numbers. So if we divide that by 100, so if you do 3 divided by 100 in your calculator, you get 0.03. So that's our rate raised to whatever the time is. And this time they're using T for our independent variable. Now be careful, because I can look and say, I know it's definitely not 1. And I know it's definitely not 3, but 2 and 4 look very much alike. So if you were to not do the work first and go directly to your answer choices, you might choose 4 by accident, when we know here that 2 is actually the correct answer, because 1 plus 0.03 is the same thing as 1.03. All right, and please make sure on these multiple choice questions that you are showing justification for your work. That's also true for your classwork problems. Now, we can also talk about decreasing exponentials. So if we look at exercise 3, state the multiplier. Remember, that multiplier is the 1 plus or minus the base, all right? Or plus or minus the rate, I'm sorry. I'm going to remind you one more time. Initial, 1 plus or minus the rate, raised to the time. This piece here that we're actually raising to the time, we refer to this whole piece as the multiplier. If you remember from our a b to the x, it's our b. It's what's being raised to the exponent. So exercise 3 says state the multiplier base you would need to multiply by in order to decrease a quantity by a given percent listed. So again, we're going to have to do a couple of things first. The first thing I'm going to do is have to realize that 10% is the same thing as 0.10. Some people know enough to move the decimal point over 2 places, or divide it by 100, same thing. So now if I want to decrease by 10.10, remember it's going to be 1 minus 0.10, which is going to be 0.90. So my multiplier is going to be 0.90. So the same thing goes here. This 2%, move it over 2 places, you get 0.02. So my multiplier becomes 1 minus 0.02, which is 0.98. 25% is 0.25. So 1 minus 0.25 is going to be 0.75. And 0.5%, be careful here. This is a little, I'm going to even write this out. 0.5%, we're going to move that decimal point over 2 places. So this is going to equal 0.005. So 1 minus 0.005, oops, I said 5 and I wrote 2. Is going to be 0.995. So what have you noticed about all of our multipliers here? I'm going to remind you that this time we're decreasing because until this point all of our multipliers have been above 1, 1.03, 1.10, 1.25. But now we're talking about multipliers that are less than 1. That's kind of a telltale sign that we're going to have a decreasing exponential function. Remember when we did these in graphs and our multiplier was less than 1? It was greater than 0, but less than 1. We had a decreasing exponential function, and that's exactly what we're going to be talking about next. Again, formal formula here. Don't need to understand it as long as you're realizing that multiplier, the only difference between what we did last time is that multiplier is going to be 1 minus the rate. So make sure it's important to use your annotating skills to make sure you're realizing when you see words like decreasing or decaying. So exercise 4, if the population of a town is decreasing by 4% per year, so almost right away I want to say, well, decreasing 4% a year, I'm going to rewrite that as 0.04 right here on my notes. And started with 12,000 residents, 12,500 residents. All right, which of the following is its projected population in 10 years? Show the exponential model you use to solve the problem. So our initial amount is 12,500. We're decreasing, so it's 1 minus that rate of 0.04, and the time they give us is going to be 10 years. So once we put that whole thing into our calculator, we come up with 8,310, 8,310.41. Well, obviously we have to round that, so here's the answer right here. We don't have 0.41 people, so most of the time they will ask us to round populations. Write down what you need to and meet me at exercise 5. Okay, here we go. Exercise 5. The stock price of Wind Power Inc. is increasing at a rate of 4% per week. Okay, so Wind Power Inc. is increasing at 4% per week. Its initial value was $20, initial value $20 per share. On the other hand, the stock price of Gerbil Energy is crashing or losing value. So it's losing, so Gerbil Energy is losing value at the rate of 11% per week. And if its price was $120 per share, when wind power was at $20 a share, after how many weeks? After how many weeks will the stock prices be the same? So be the same in mathematics, hopefully you're realizing that kind of means equal. So model both stock prices using exponential functions, then find the stock prices when the stock prices will be equal graphically. Draw a well-labeled graph to justify your solution. This is where a calculator comes into play. You guys won't have a calculator, so you know something, we're gonna bypass that part, but we can figure out the other part of it. So let's try and figure this out. Let's talk about wind power. Wind power is increasing at 0.04 with an initial amount of $20 a share. All right? So if we write this equation down, we know this is going to be 20 times 1 plus 0.04, right? 4% per week. I kind of missed that part. I did that without talking about it. I changed that to 0.04, raised to the time. All right? So now let's talk about that other one, Goebel energy. I don't know where that came from. Goebel energy is decreasing by 11%. So we know decreasing is 0.11. And we know that initial amount is 120. So that formula is going to look like 120, 1 minus 0.11 raised to the time. So to find out where these two are the same, we're simply going to set them equal to each other. So we're going to say 20, 1 plus 0.04 is equal to, I'm sorry, to the t power, equals 120, 1 minus 0.11 to the t power. Now, you can't solve this because unfortunately in here you are not able to solve anything that has the exponentials unless we can bring it down to the same base. And in this case, I don't think we're going to be able to do this. 1 plus 0.04 to the t power is equal to 120. 1 minus is 0.89 raised to the t power. So we could put both these functions into our calculator and determine where they are equal. All right, so we're not going to do that now, but if you want to do that tomorrow, remind me and we'll make sure that we go over it. Okay? So nothing here should be terribly new to you. This is a lot of things left over from Algebra 1 that we're just kind of taking up a notch or two. We will be doing 4.6 classwork in class on the next time we meet, and then you'll finish that up for homework that night. Okay? So until then, make good choices, make sure you're copying down your notes, and please make sure you're really understanding your notes. Just copying them is not going to help you or me. It's really going to, all it's going to do is it's just wasting your time. All right, so make sure that you're paying attention to it, you're really understanding them, and you really use them to your advantage. Okay, until next time, make good choices, and I'll see you. Bye-bye.